Hello everyone, welcome to the GATE NPTEL lecture course. Today we are going to solve question number 22 from GATE 2018 examination. In this question, it is given that a light beam of intensity I naught is falling normally on a surface. The surface absorbs 20% of the intensity and the rest is reflected. What is the radiation pressure in terms of I naught by C? And we have to find the multiplication factor to that. So basically what we are given is we have an electromagnetic wave which carry energy and momentum and it is kind of reflected from a surface. The 20% of the incident light is absorbed while the remaining 80% of the incident light is reflected. So what is the pressure that is exerted onto this surface? So basically we have to find this radiation pressure. So the pressure, as we know, is given by force upon area. So this quantity will become rate of change of momentum divided by area. We can also write this quantity as del P by del T is the rate of change of momentum divided by area. So this is the pressure. And in case of electromagnetic wave, this quantity is given by I naught by C for the case when there is a perfect absorption. That is, if I consider the case when there is a perfect absorption of the incident light. In this case, there is an incident light, it is falling on a surface and it is completely absorbed. So if initial momentum of this light is P, then the final momentum of this light is zero. So that the change in momentum, which is P initial minus P final, is P. In this case, the pressure PR, which is equals to P by delta T into A, is given by I naught by C. Now the formula can be calculated using this lecture, in which this formula is completely derived, how this I naught by C is coming. So this is the case when there is a perfect absorption. So the second case is that we have to find is there is a 20% absorption, which implies that there is an 80% reflection here. So we have an EM wave which is falling on a surface, and if initial momentum of the light is P, then final momentum when it is reflected is 0.8 times of P, and remaining momentum is absorbed. So that means that the change in momentum is given by P initial minus P final. P initial is P, and since the direction of P initial and P final is opposite, therefore it is negative of 0.8 times of P. So the change in momentum is 1.8 times of P. So the pressure is given by delta P by delta T into A. So 1.8 times of P by delta T into A. So the quantity this is equals to I naught by C. So therefore, the pressure in this case will become 1.8 times of I naught by C. So we have to find this factor 1.8 that is coming before I naught by C. So factor 8 is 1.8 here. Thank you.